Human error. When we planned to do something right and it went wrong, we either did not do it properly or what we did was not the proper thing to do. Humans can perceive change around us. We discussed the error change phenomenon already. When we make an error, it changes the status quo. That change should be perceptible. Sometimes, however, not so much. Is the operator aware of the change? Not in our texting example. The car starts to drift, the operator is distracted, and the operator doesn't notice the perceived change until it might be too late. We can be more situationally aware of changes happening around us by focusing on that, but we cannot be 100% functional at 100% of the time. As such, while we can be more in tune with our environment, we should also design organizational systems to alert the human when changes occur that deviate the system from the intended path. In our previous example of the driver who is texting while driving, rumble strips along the side of the road alert that driver that, hey, we have a deviation from our intended path and it's time to start paying attention because otherwise catastrophe is imminent. An aviation example, aircraft alert the pilot when arriving at an altitude to level off or when leaving an altitude. That helps to make sure that the pilot is aware that a change is happening or that a change is needed. Your Wigman and Chappell text goes into great detail in each of the 6 human error perspectives. Your PowerPoint summarizes each of them. In this video, I'm just going to hit on 2 high points. First, when you study the cognitive perspective, you will learn that there is a lot of sensory input into the operator that needs to be processed and then output into some form of action. I want to use this perspective to illustrate just how this understanding can help us enhance safety. They're not just philosophies or perspectives so that we can talk about them in class. Really, they're there to analyze these perspectives in order to learn from them in order to enhance safety. So let's talk about this. There are opportunities for error in the cognitive perspective. For example, cues may not be perceptible. They might be too low volume, too undetectable. So cues might not be perceptible. Secondly, knowledge may be lacking. So if the cues are there and prominent enough, maybe our crew member hasn't been trained well enough. Or, if the cues are okay, the pilot's been trained well enough, maybe the pilot doesn't have the skill level necessary. Each of these faults, perception, knowledge, or skill, could be caused to blame the one who made the mistake. However, we ought not do that because if we do, the same thing will continue happening. Instead, we can analyze the mistake into greater detail. Let's look at that. Wigman and Chappell illustrate a flowchart that can help us determine a little more depth of why the error was made in the first place. Understanding what type of error was made can help us understand what organizational level strategy might be able to help mitigate that for the future. For example, let's just work down through this very quickly. Let's say we've already done that, and we get to this level. Did the pilot choose a goal which was reasonable given the circumstances? Let's say that the pilot with passengers chose to depart for their destination in the face of deteriorating weather. So weather's getting bad, the pilot departs anyway. That was a decision error, and that was with the goal of getting to their destination was not reasonable under the circumstances. So the answer is no. We move this way. It was a goal error. That can help us then understand why the goal error occurred. Maybe the company is more focused on arrival schedules than they are about safety. Or maybe the passengers were pressuring the pilot. Or maybe there were other external factors. But this can give us great inroads into understanding if the organizational level can help put barriers in place to influence decision making. In this case, for example, there could be a dispatcher, somebody who's not emotionally attached to the success or failure of the mission. A dispatcher can look at the weather and say, Mr. Pilot or Miss Pilot, no, you cannot go because, well, there's deteriorating weather out there. You should know that. That type of organizational level could help mitigate some of that danger. Here are some examples that are in aviation as a result of the cognitive perspective. What we've learned from the cognitive perspective, these are some areas in aviation that have actually come in to enhance safety, to help pilots process information better. Knowledge gained through study, such as the cognitive perspective, and root cause analysis, getting to the root understanding, not just chastising the pilot, but understanding why the pilot made a mistake in the first place. That can make great inroads into future enhanced safety. These particular enhancements help reduce the pilot's task demands. That enhances the cognitive processing capabilities during high workload situations. So these are all designed, these are just examples of areas that have been designed to reduce the pilot's cognitive workload, therefore enhancing the cognitive processing capabilities during high workload situations. So that can enhance safety. That's just one example. The other perspective that I wanted to talk about during this video is the organizational perspective. Organizations play a role in managing, mitigating, or even aggravating human errors. When origins or root causes are not controlled, it can lead to a domino effect culminating in accident and injury. Wigman and Chappell propose 4 P's of flight deck operations. I hope you're starting to see by now that there's a trend that with every mishap there may be a couple, 1 or 2, maybe a couple more immediate failures. That's at the sharp end of the stick. That's the immediate failures, the active failures that caused the accident in the first place. But there are generally many root causes, or many more root causes and other contributing factors throughout the organizational levels that could have prevented the mishap in the first place. The 4 P's are no different. Management designs organizational philosophy, policies, and procedures. That's a management function. They design those, the written policies and procedures, and then they follow that up with action. As a result of that, and the resultant training and checking, the crew then performs practices. That is, the crew does stuff in the cockpit that they were trained to do. When a practice, something the crew does in the airplane, causes a mishap, chances are that something at the management level led the pilot down that mistaken path. Likewise, moving from Wigman and Chappell to Latino in your text proposes a list of the top 10 things that contribute to decision errors. Latino in your PowerPoint cover this list in detail. I want to point out how each of these contributory factors can help us during root cause analysis investigation. These are the contributory factors that contribute to human decision errors. Top 10 things. Let's go through them very quickly. During investigation, look for signs of leadership weakness. During investigation, look for characteristics of a poor accountability system. Make note of a distractive work environment during investigation, noise, interruptions. Also, during root cause analysis investigation, look at the employee's history, the person who was on the sharp end of that incident or that accident. Look at the employee's history. Check for fatigue or life changes. Also look for indications of complacency, number of years on the job, low complexity. Be aware of work stress, time pressures, whether real or implied. Most of the time pressures are more implied than they are real. Look for lots of time doing the same thing over and over and over again. That can lead to overconfidence, automaticity, which is automatic. The person goes on to autopilot when they're performing the task. Look also for lots of experience without much recent experience doing the job. That's kind of the opposite, and that is downtime. No recency of experience. Check how much experience the involved employees have on the job. That can flag an investigator to look for possible overconfidence having played a role. Do new employees have the opportunity to perform tasks the first time with a seasoned employee or instructor present? Is that training documented? Are there provisions to make sure bad habits are not conveyed from a buddy system? Look for adverse factors in the communication process. Communication is a big part of safety. Look for input data, subjective factors, physiological or psychological functions. Look for complex or cumbersome procedures manuals. That is far more common than we'd like to admit. Look for training program execution, budget cuts of the training program. Look for those things during investigation. And finally, look for new technology in the organization and how that technology was implemented on the job. This information can be very beneficial in conducting a root cause analysis or reactive, but it's also very beneficial for helping proactively manage safety. You could go through this list of 10 things in your company and see, without even having had an incident or an accident, you can go through these 10 things and really work hard to set up the system for success, for supervision, for accountability, to mitigate distractions and the like. Given all of this information, though, the organizational response to a mishap should not be a witch hunt looking for the person to blame who was on the sharp end of the accident or the incident. It should not be a witch hunt. That will cause employees actually to shut down, to hide vital information that can be used to enhance operational safety. The last person in the mishap chain is usually the greatest resource of information. They're also usually the victim, so they did not probably intend to cause the accident. Now, recognize when you're investigating that there are events above the human that is at the sharp end of the mishap that contributed to the event as well. Seek those out for finding and fixing. Those higher level organizational events will no doubt make the greatest impact for safety.